Yeah, hi everyone. Sorry for the delay. I hope I'm audible, all of you. How are you doing? Hi. Um, yes, considerable amount of people joining in. Sorry for the delay from Let's Upgrade team, and we'll be starting soon. Hope you had a look on Matplotlib yesterday, the different sections of Matplotlib, how it is getting work. Yeah. Thank you for the feedback. Hi, good evening. So today we'll be having a look on Seaborn, and I will be sharing one more Jupyter notebook, which is on Google Colab. I will be sharing that with you. I am posting that on the community forum as well. So just a second. This is a exercise thing. I'm doing it right now because the next section is Seaborn, which is going to be a little bit different. So for Matplotlib, this is the one thing which you can check it. 1 second. And after that, I'll share my screen and we can start understanding Matplotlib and Seaborn, which is the child library of the same. Okay. Community forum and anything, and I think anyone from Let's Upgrade can do this. Okay. Yeah. I will be posting it in the community forum soon. Yesterday's assignment was more about Matplotlib. You have to understand more about Matplotlib, and you have to check on the documentation where everything is visible for the Matplotlib examples. That's what you were supposed to do. Today is more on a different way altogether. So let me share my screen. Just let me know if you can see my screen. Okay, just let me know if it's visible. Can you see this? My screen? No, you don't have to submit anything for yesterday. Today, I will be giving one activity on the forum, which you'll have to do. Yeah, that's great. So, this is the official website of Data Visualization Library, Seaborn. So, guys, we had a look on Matplotlib. So, I guess everyone has a perfect understanding features of what is important in Matplotlib, right? So this is what is all about Seaborn, and Seaborn is purely a statistical data visualization library. How many of you have heard about Seaborn, guys? Okay, what do you mean by statistical data visualization? How many of you are very good in stats? Can I get the response? Those who are good in stats. How many of you are really good in stats? Like, I'm not speaking about the high level kind of statistics things, just the basic thing like mean, median, mode, and yeah, correlations, probability distributions, and everything. So Seaborn is a next level of data visualization. It is not just mere two-dimensional kind of thing. It can be taken collaboratively with a different type of structures together. And it's like, suppose I want to do a multivariate kind of analysis. When I say multi, it means that I'm not restricting to only two variables. Now, till yesterday, we had a look on x and y axis, right? We had a bar plot where we check for what is there in x and y axis and everything. So, we are restricting ourselves on using only two variables, correct? But here in stats, we are not restricting ourselves to two variables. It can happen that we may think about many variables at a time. Like someone mentioned just few minutes before I saw in the chat, it was all about correlation, right? So, have you heard about correlation or everything? Those who know about stats, they'll know much better. Or those who are into linear regression and everything. Yeah. Okay, no, not a problem. Everyone need not be masters in stats. At least you have done this basics in your school and college days. Correlation, where we check up. So, if you know the correlation, this particular correlation comes up between -1 to +1, and 0 refers to no correlation. So, such kind of examples where we want to understand little more about the data, then we jump into Seaborn. If you see the official documentation right now, it's clearly visible that Seaborn is based from Matplotlib. It is the one which is created from Matplotlib, right? So Matplotlib is like a base library. That's what we started yesterday. We understood about Matplotlib, and based on that, we are featuring the different libraries together. And that's what is all about Seaborn. Seaborn has a base of Matplotlib, or you can say it was born with the basic functionalities of Matplotlib, and it has certain extra functionalities which gives a boost for statistical data visualization. So suppose I want to know any statistical data visualization, like the one example I gave for correlation, or suppose I want to know three variables together, instead of having a two-dimensional plot, I can have something which is with four variables and five variables together. So today we are going to take a little more on an intermediate version of data visualization, which is a statistical data visualization, that is Seaborn. The official website of Seaborn is seaborn.pydata.org, which you can see it right now. Can you see this? This is the URL. You will see everything over here. I always refer to the official website because it is really beneficial to see the latest versions which is coming up, to download and everything. So this is Seaborn features. Can you just see? This is one of the few examples. This is a scatter plot matrix. So can you see something which is really exciting as compared to yesterday's example? Are you able to see something different with different color shades? Yeah? Can you see the difference now? Yesterday it was just like a black and white kind of a diagram where we were focusing only on 2D thing. Yeah, so you can see that I'm able to elaborate more about visualization. Obviously, when we put some color shades, when we have the grouping of the data, it adds more information, right? Yes or no? So this is actually a scatter plot kind of a matrix where it's like a grid kind of a structure. So you can see this. One more example, just like let's have a look on simple examples as of now. Then with the Google Colab link, which I have with me, I will just explain you what is done in the Seaborn example. You will take this as an activity and do upfront after my session, because in the particular time limit, it's very difficult to help simultaneously. Like I'm writing a code and you're also writing, so that is not possible. So let's understand what I want to show from Seaborn. This is a time series plot. Yesterday we had a look on line chart, right? You remember? All of you, just one line chart. So imagine here I'm showing the line chart with certain legends. So you know what are legends? Yeah, legends. See this part, guys. I'm asking a question with such a way that just have a look. Can you see this part? I'm shading it. The region having blue and red color thing, and then we have an event with some lines. Correct. So this is like a time series plot with the error bands. So it is having a legends which is showing that this blue color refers to something, this red color refers to frontal area. So with this, am I elaborating more about the line chart feature? Is it easy, beneficial? Yeah, that's right. The upper right side details which shows about what are extra you have for the particular color thing represents the legend. Okay. So this looks even more elaborative, right? What do you think, guys? So are you now okay? I'll zoom it. Just hold on. Yeah. Can you just see now? I think it's even more better. So this looks even more better. Can you just see now that this is even more elaborative, and it's really fun to have such kind of graphs, right? So these are the legends, guys. So I just want to give the examples because this will help you to understand what exactly seaborn is. Right? Now, let's have a look on one more plot. I don't know how many of you have an idea about it. Do you know what is a box plot? Any idea? Have you heard of a box plot? Okay, I get a mixed response. Someone is saying yes, someone is saying no. So, just a shootout question before I enter to the coding interface. What is a box plot? Why do we use it? Why there is a need of a box plot? Okay. Guys, box plot is more of distribution of a data. It divides your data into four quartiles. It is something which shows up that there is one concept for data analysis, that is outliers. Have you ever known about this term outliers? What are outliers? Any idea? Outliers are some data points for people who do not know about it. Outliers are some data points which goes to extreme endpoints. So suppose I'll give you an example. I say age of a person as 200. Think about it that I have a record of people who have a bank account with my particular bank, who have opened a savings account, and the age of the person is 200. It's given in the data that it's 200. Is it possible for a age of a person, like a human being like us, having a uh, age as 200? Is it possible? That's obvious, right? We can't have age as 200. Yes, let's take, for example, let's take the upper limit as 100. That's also very minimum, right? So these are the data points which is available in the data, which is like you cannot completely trust the data. Sometimes the data goes to extreme endpoints. Basically, these are some of the error points which needs to be chucked out. Box plots are those plots which helps us to identify the outliers. That's a key aspect of box plot. They are those plots which helps us to identify that how many of the data points in my particular data column has such outliers or such error points. And the other plus point about box plot is it divides the data into four quartiles. So when I say quartile, what does quartile means? When I say give me a quarterly report, what does that mean? Suppose I say that give me a quarterly report, what does that mean? You're dividing it by 4, right? Suppose 100 divided by 4 shows up 100 and 4, that is 0 to 25, 25 to 50, 50 to 75, and then 75 to 100. Correct? Yeah. So suppose my data is 100, then we are dividing it into four parts. That is a quarterly kind of a report. Correct? So this is what is quartile. Taking your data overall as 100%, and it is dividing into four quartiles. That is from 0 to 25, 25 to 50, 50 to 75, and 75 to 100. Is that clear, all of you? What are quartiles? So can we now jump to the example of standard deviation is a different concept. Standard deviation is something which is square root of variance. It helps us to understand how much my data is away from the mean. Okay, so now let's have a look on one example for Seaborn. I will be sharing this Google Colab link on the forum. So you don't need to worry about it. Okay. For some reasons, I'm just switching off my cam. I hope you're able to listen to me. There is some network issues at my end. Just hold on. Yeah, can you hear me, guys? So let's focus on the Seaborn thing that is available over here. Okay, that's great. So let's get started with an example. So first of all, Let me show you the example which we are going to use. Let me take you to this URL. Just hold on. I have a data with me. I'm going to share this. I'm sharing a data file in front of you. Just let me know if you can see. Are you able to see the screen? All of you? Okay, 1 second. 1 second, 1 second, guys. Just hold on. Are you able to see right now, guys, the data file? Just hold on. Okay, just a second. Okay, I'll just take you to my main screen. I just wanted to show this in the Excel file. Yeah, are you able to see it right now? Okay, just a second. There is some technical glitch which is going on. Yeah, just hold on. Yeah, we got it. I want to show Excel only, but I'm trying to reshare it again. Just give me 2 seconds. Yeah, this is the data. The URL of the data is available in Google Colab. Are you able to see the screen? All of you? Yep. Now I'll share this in Excel, how it looks. Let's have a look of the same file. Okay. Let me share it in Excel for you. Excel is the data, that is the CSV data, which is available in Microsoft Excel. It's not the Excel file. It's actually a CSV file. Can you see it now? Yeah, guys, just hold on. We are just focusing on the technical glitch which is doing. Okay, anyways. Yeah. Can you see my screen now? This is the Excel file. Maybe it is taking time for loading the screen. Yeah. So this is a data, it's a big mart data, which has the different sections. Can you see? Item weight, item identifier, item fat content, item visibility, item type, item MRP, outlet, and different kind of scenarios. So this is just an example for say for do you know about DMart, Big Bazaar, where we are actually focusing on the data and we are understanding more about the data. So I'm zooming in. So can you just see the different columns? So this is one. So say for example, I'll take you to the first one. This is item identifier, item weight, item fat content. So in a DMart or a Big Bazaar, we have a list of items which is available, and the details of the items are clearly mentioned over here. Okay, can you see it now thoroughly? Yeah, you can check the name over here. I need not widen it everywhere. You can check it, it's quite zoomed now. Item visibility, item type, item MRP. So we are going to do a data visualization of the same example with the help of Seaborn. We are going to use Seaborn. Okay. Now let me take you to Google Colab. So what are we going to do? I'm going to call for the necessary libraries for a data visualization. As you can see it over here, we are going to understand line chart, bar chart, histogram, box plot, violin plot, scatter plot, bubble plot, and pie chart. And some of the concepts which is we have already done. One of the example which we had was for histogram, which is the density plot here in Seaborn. So we are importing the necessary libraries. Now again, to check that if Seaborn is already installed in Anaconda framework, yes, Seaborn is already installed in Anaconda framework, and I'll show you here. Can you see the command prompt, all of you? Like we did for yesterday. Like we checked that is matplotlib already installed or not. So let's have a look. So it is conda space list. It shows up the list of packages which is already installed. As it is arranged in the alphabetical order, so I'll just scroll up little. Now from here, you can just see that if Seaborn is already installed or not. I'll highlight and show it to you that Seaborn is already installed in Anaconda. So you need not install it. And okay, so we can use from matplotlib, but Seaborn is altogether a different thing. So it is like you're using a parent to get the features of a child. So you have to use matplotlib and Seaborn if you need a better visualization. So if you want it like Seaborn, it's not understood that you want the features of Seaborn when you are importing a parent library. So the question which comes from you, Ganesh, is that I'm importing a parent library expecting that I will get all the features which its child has. That's not possible, right? So we'll have to import Seaborn separately. So as you can see here, Seaborn is already installed. Okay. So to install Seaborn, the best package which I can say, or the best way which is doable, is nothing but pip install Seaborn. So I'll show you what comes up over here. Pip install pip install Seaborn. If your package is not installed, if the library is not at all installed, then you'll have to follow this command. But for now, it's already installed in my system. It shows up requirement already satisfied. This is just a brush up to make you understand what we did for matplotlib. We are following the same features for Seaborn. Okay, clear all of you? Yes, so now can we jump to our Jupyter notebook in Colab? So we have this Jupyter notebook. So I have taken some extra libraries over here. So one of them is NumPy, which is a numerical Python. And pandas, if you remember yesterday also I gave an example for a salary thing. So pandas is nothing but a data manipulation library. It follows a data manipulation feature. Yeah, the installation, see, if you're installing Anaconda, guys, you get everything under one roof. That's what I want to repeat it. That's why I'm keep on emphasizing this fact that please install anaconda.org so that you will get everything under one roof. Okay. Cool. So now I have taken NumPy and Pandas. Now I'm also taking Matplotlib. Now this thing, this feature, are you able to see the code thoroughly or should I zoom in little? Can you see it now better? It's visible? Yeah. So we have person Matplotlib inline. Can anyone think about it? Why we have this feature of inline? Why do we need this feature of inline? This inline is actually used more when we are using Google Colab or something so that I can get the plots of Matplotlib in this particular Jupyter notebook itself. It will not populate as a new window. Sometimes it happens that whenever we are plotting a visualization, it comes up, the output comes up as a new window. I do not want in a new window. I want here in my Jupyter notebook itself. So that's why I'm saying person Matplotlib inline. Clear? Yeah, to get the result in the same notebook. That's right. Okay. I'll come to this part later. Jump into this part later. But let's do one thing is that I'm going to call my so-called big mart data, which I opened in front of you a few minutes before inside Excel. So what I'm going to do, like I did yesterday, where we had two columns of a salary data, one with the number of years of experience and one with salary. Here we are going to convert that particular data into a data frame. And this is possible with the help of pandas function read underscore CSV. So I'm reading that data set and converting this into a data frame. If you want, I'll show you that this particular data frame looks something like this, the same data tabular form. Can you just see? The one which we had a look in Excel. So data underscore bm dot head is actually converting that into a tabular data. Are you able to see this? This is nothing but the same data which we just saw in Excel. The same one. Let me zoom in. Yeah, this is the data. Okay. So we are converting that data into a data frame, and there is one feature called as visibility scale, which I am multiplying into 100 so that I can have a huge amount. Now this something is not mandatory. For now we are not focusing on visibility scale column. We are focusing on what all different plots are available in Seaborn. So let's have a look about that. So you can see that I'm taking this data into consideration, and now I'm jumping on creating a basic plots in my particular library. So we have line chart, we have bar chart, pie chart. So let's do the same tradition which we did yesterday for Matplotlib. Are you ready, all of you? Just a second. Okay. So first is line chart. Line chart is a specularity. If you want to just check in, line chart is done in the similar way in Seaborn. Now in Seaborn, I've given a nickname as SNS. If you just go to the particular imports which we have done, right? Can you see here? I've called for import Seaborn as SNS. SNS refers to the nickname of Seaborn. So I just want to say that Seaborn has a pure name, but I've given the name as SNS. You can give to any name which you want, but these are the standard conventions which are being followed. Okay. Now I'm zooming in little below. So line plot is a function of Seaborn where it takes the x and y value and the data frame. If you're calling for a data frame, it will take the necessary data frame into consideration. So for now, just remove this particular part and I'll show you the output. This is going to be a very big line chart because it is going to take all the values of a data underscore bf. Just have the output. So I'm taking item weight as my x-axis, item MRP as my y-axis. Now, why do you think I got a cluttered kind of a line chart over here? Any idea? Why we have got a cluttered line chart over here? This is the x-axis, which is item weight. This is the y-axis, item MRP. It's a very big data, right? So that's why what I did earlier, this colon 50 is nothing but to take the first 50 records, or you can say the first 50, I'm slicing it out. I'm taking only the first 50 set of values so that I can get a line chart even more better, clearer. Obviously, this is not a part of seaborn analysis because this comes as a part of pandas. So yeah, we'll see that if we have any session on pandas, well, I can explain it thoroughly. But for now, the basic syntax is x as some value, y as some value, and data equal to some data frame. The data frame which we had converted just now. So the line plot which we are creating is nothing but the line chart. So are you able to see this line chart? Any difference between the line chart of Matplotlib and this one? Or is it completely the same? Are you able to figure out any difference? No, you can't put data.head because data.head 50 is purely a different function altogether. That can't be taken as a parameter. So any difference, guys? Yesterday we checked on one example. Is it something like I'm not giving X label, Y label? Can you just see that? And I'm getting a default color and I'm able to get a grid like structure. Yeah? Yeah, I'm getting a grid like structure over here. So is it something like which one is more satisfying or smoothing? Is it something the Seaborn one or are you happy with the Matplotlib one? Which one looks more elaborative? Any guess? Seaborn is better from now only. Now only you're ditching Matplotlib. Okay. So yeah, Matplotlib is a basic library, guys, because it was just created for the 2D structure. But yes, Seaborn has even more better features. It has more fancy colors to show the interpretation and it focuses more on statistical concepts. That's the best part, which is not doable usually in Matplotlib. Yeah. So did you check out for this line plot? Can we go to the next one? Can we have a look on bar chart? Bar chart is the same one which we saw yesterday, the bar plot. Remember bar, plt.bar. So we are taking the same one, item type and item MRP, and I'm plotting a bar plot over here. So in Cborn, you can create a bar plot using a function of bar plot, which is nothing but a bar chart. Now, the important aspect to understand here is that we need to write an extra code to group the category wise of the data. Okay. Now, let's not focus on grouping category wise. What does that mean? But let's focus on the syntax as of now. If you see, the syntax is same as that of the previous one, where we are giving x axis as this, y axis as this, and my data equal to the data free. Now, what do you think colon 5 will do? Will it take the first 5 columns? Yes, it will take the first 5 columns. It will take first 5 columns into consideration and it will take only the category of that first 5 columns with respect to item MRP. Okay, we are doing first 5 columns because we don't want a cluttered graph. I can show you one small example by taking all the data BM. Let us see how the bar plot looks. Isn't it looking more cluttered, messy? Can you see the bar plot now? Are you able to see what is there in item type? It's not clear, right? Yeah, guys. Are you able to figure out what is there in item type? No, it's clumsy. That's true. You have it very clumsy, way too cluttered. So that's why I'm slimming or trimming it out for the first 5 columns. Just a second. Yeah. First 5 columns. So now if you see it, it's clearly visible that I have dairy, soft drinks, meat, household, banking goods. So accordingly, I have my bar plot over here. Can you see the bar plot count properly? Now, another question. Now, is this bar plot more soothing as compared to matplotlib? Sorry. Yeah. Okay, just a second. I will be sharing the CSV file through chat. Is it fine? Just hold on. I'll just reshare my screen. I'll be sharing the link of the CSV file. All you need to do is click on Control S and save it, and immediately you can work it, or use the same link. If you know the coding standards and everything, I'll be sharing both the links in the chat box so that you can refer and use it. Just hold on. If you are there in community, it's already there, given over there. I'm sharing it, both the values. Just hold on, guys. I'm just putting it on the chat of your so that you can refer it. Are you getting the CSV file, all of you? If yes, then I'll share my screen and let's proceed with the next example. This is a CSV file and also I'll sharing the Jupyter Notebook code. Are you able to see the screen right now? Okay, just a second. This is the Google Colab link which I have dropped in. It's a problem with sharing of the screen. Just a second. Yeah, can you see the screen right now? Visible? Cool. I have shared both the links, guys. Can you scroll up in the chat? The Google Colab link is also there. I've dropped in again. Please check. Yeah. So this is one example for calculating the MRP. Can you just check this part? So which one is more soothing? Is it the bar plot of Matplotlib or is it the Seaborn? Which one looks more better? Obviously, I know the answer, but still I'm asking. Please scroll up in the chat window right now where you're putting it. I have dropped both the CSV files and the Google Colab. Guys, it was already put in the community. Next time, I will not do this. Please check on the community thing. Seaborn looks better. Yeah. Now, can you go to the next one? Can we have a look on the next one? I hope you are able to open the Google Colab link. You can't edit the changes. You can view the changes. Are you able to view the code? All of you? What is a histogram? Remember histogram which we did yesterday for Matplotlib? You can create a histogram, and histogram is more similar to that of a dist plot. In dist plot, specifically for Seaborn, is a distribution plot. Histogram is more about distribution, right? It focuses more on distribution. Yes or no? Can you just see that there are multiple options for creating a histogram thing, but when it comes to the one which we have right now, this is the best example. This example is for MRP. Now, item MRP is something which helps us to understand how much products have higher frequency, or I can say that suppose the products are from this range to this range, okay, and the products are more towards 500 or $1,000. So that distribution is available with the help of dist plot. Can you see this dist plot? Yeah. Dist plot is nothing but dot hist of matplotlib. What we did yesterday. We created a plot like plt dot hist. So similarly, we are doing it here, sns dot dist plot, and we are putting it here. So if you run the code, just see the output which is visible. Can anyone help with this guy? Because I'm dropping the Google Colab link again. Samray, please check the Google Colab link which I have put right now. The name is visible of mine. So this is just for you guys so that you can have an interactive session with me right now. Next time, for the next session, it will not be done. It will be posted directly on the community so that you can check it. Okay. So I have a box plot. Can you see the box plot here? All of you? Now I wanted to know that for item outlet sales, how many outliers are there? Or let us do for item MRP, because anyways we are checking out for item MRP, right? So is there any products which are having more outliers or something which is going beyond the range? So we can do that here. Just scrolling down. And I, instead of outlet sales, I'm putting outlet MRP. Some coding part I want to do in front of you guys. So this is item MRP, and the orientation of the box plot is either having in the vertical position or the horizontal position. So I'm putting here in the vertical position. Can you see the box plot now? I do not have any outliers for MRP, which is a good thing, right? The CSV file, okay, guys, just hold on. I have shared a link with only one reason so that at least you can listen to my lectures. The CSV file is here, guys. pd.read underscore CSV, and the URL is given over there. This URL, if you follow this link, this URL has the big mart data.csv. So kindly pay to the different syntax which I have. You can play around Google Colab whenever it is possible, because this is available. This is my own Google Colab repository of a notebook. I'm not going to delete it. So kindly pay attention of the different plots which I'm trying to do. I did it for item MRP, which is showing that I do not have any outliers. So there are certain scenarios where I do not end up to any of the outliers. The data is completely pure. That's possible. Yeah, I'll show the example with the outliers. So I'll just take it to the previous one, which is item outlet sales. Now I want to know that what was the sales of each and every item. Now if you just see the output, I'll just scroll up. Can you see the output? We have a lot of outliers over there. Now when we have many outliers, it is ideally suggested that you cannot proceed further with the data which you have. The only suggestion is you'll have to treat those outliers. Treat those outliers in a way is nothing but to remove those outliers. That's the only suggestion which is doable. Okay, is that clear, all of you? Any questions for the box plot? So yes, box plot can take up only one data, but if you want to show box plot, okay, so let me say that I'm removing this column. I do not want this column. I want to take the entire data frame. So you can see that it is coming up as with some error, because there are many columns with the string values. So I cannot take box plot for the entire columns. I'll have to specify some columns. So I'm just changing it. So you get errors even in Google Colab also, guys. This error was done deliberately to make you understand that if you change the parameter, accordingly your output will also change. Yeah, so box plots are most important feature in Seaborn. Box plot is not there in Matplotlib. It's only available in Seaborn. So that's again a plus point. Clear, all of you? How to know the outliers value is a different concept altogether. It is a part of exploratory data analysis. Here we are focusing only on visualization, like to identify, to see that do we have any outliers and what to do if we have outliers is a different part that comes as exploratory data analysis. You can take up two columns also, no problem, but you cannot take up string values because string values has nothing to do with statistical data. Anything comes up with a statistical data should be purely a numerical data. Can I calculate ABC, XYZ, and can I calculate the mean of those values? That's not doable, right? So you'll have to strictly restrict yourself to the numerical data. Okay. Can we have a look on the next one? Violin plot. Sorry, I have a cough today. Yes, you're right, Vishnu. The values inside the C, this is the actual range. In a brief, I'll tell you how the box plot looks. Let me take this orient horizontal, or let me remove this orient part. Just a second. Hmm, horizontal. Okay. One second, it's not happening, I guess. Orient as H. Okay. I'll figure out this. This maybe I'll have to restart the kernel. I'll just show you. The range of this particular box plot starts from this dash. Can you see this dash? Till this dash. So this is from 0 to 100 percentile. It is dividing this part, this 0 to 25, 25 to 50, 50 to 75, 75 to 100. Okay, let me show you with some examples in Google. I'll get an image. So say I have a box plot here. Yeah. So can you see this one? This image. So this is min, this is max. The middle line which goes up is median. Okay. So minimum to this one, this Q1 is 25. This to this is 25 to 50. So 50 is like median, right? It is going to the middle value. Then from 50 to 75, 75 to 100. So anything which exceeds above max or which is below min is treated as an outlier. Yeah, the upper limit and lower limit, anything which goes to the extreme endpoints, which is exceeding the upper limit and which is going below the lower limit, are treated as outliers because they are not fitting inside the range. So suppose I say age of a person is -1. That's not doable, right? I can have an age of a person of or a human being in months, in decimals. That's okay, but I cannot have an age of a person as -1. So that is like below minimum. It's like 0 to something. So if I say -2, -3, that is not at all possible for age of a person. So it is something an outlier which goes below the minimum data point. Yeah, we have to fix the range. So if you want to see that I have outliers, so the next step of exploratory data analysis is fixing the range and then moving further. So basically it is clearing up the messy data. Okay, clear all of you? Yeah, Ankit, I can see more smiles. Are you happy or are you understanding? That's great. Okay, so let's have a look on the next example. He has a valid question, guys. Even you can ask valid question. I was more emphasizing on the box plot because of the only one reason that I don't know if all of you have a clear idea about it. So let's go on to the next part, which is similar to that of a box plot. The look and feel is changing. This is more on a quantitative data perspective, which is a violin plot. It looks like a violin. specifically. So it is more on a look and feel which has a similar features like that of box plot. So can we have a look on violin plot? The description is given over here. Violin plot is showing up something like this. So say I have item outlet sales and I'm giving a color here as magenta. I can change this color. I can give it blue also. One second. So suppose I want a color blue. Yeah. Can you see? It's a typical kind of a plot. It shows up that violin thing only. This tapering end are nothing but the outliers. Okay, let us take magenta only because this blue is more glossy in color. Yeah. Can you see this one? Are you able to see? I'm not getting any chat responses. Are you guys offended? Can you please respond? This is a violin plot. Yeah. It's more or less like a box plot, but the best part about this violin plot is that it has a tapering thing. Instead of showing dots, this tapering point shows up the outliers. So it is similar kind of a box plot, but it is having a look and feel in a different way. Honestly speaking, violin plot are not that much used for data analysis. Box plots are highly used for data analysis. So you can pick up that for reference. Okay, clear all of you? Range is not at all mentioned in the code, Vishnu. Range comes up. See, range is different for different data. It need not be same. It's going to be different for different data. Okay. Everyone clear with the violin plot? Can we go to the next example? Can we have a look on the next example? Is a scatter plot, the dotted plots which we saw yesterday. Yes, scatter plot has a different structure again, but the code of the scatter plot comes up with REL plot, which is relevant plot. Scatter plot again takes up x and y axis, so it is a bivariate analysis. Univariate, the example which we saw earlier, is taking only one variable at a time. Say, for example, histogram box plot is taking only one variable at a time, which is a univariate analysis. On the other hand, this takes up two variables at a time, that is item MRP and item outlet sales. So that's why it is considered as a bivariate analysis. If you see here, I am giving a plot here as scatter. Can you see? The kind of the plot here is scatter. This plot is looking even more better as compared to the example which we saw yesterday. So I'm specifying what is the x-axis and y-axis. I'm taking only the first 200 columns because I'm not taking everything into the data. 200 records, sorry. So if you just see this, this plot shows up the complete dotted points, the scatter. Here you can see the relationship between item MRP and item outlet sales, clearly visible. Can you see with the MRP and what is the amount of sales which is being done? Yeah, kind, because you can create any kind of plots with the help of REL plot. It's just like a count plot. You can give kind equal to scatter, you can give kind equal to some other plot. So I'll just show you the official documentation of this one. This is a valid question. So yeah, cbond.rel plot. Can you just see? This creates different type of plot. It also creates a line plot. So I'll just change this to line and just show you the relationship. You can create a line plot and a scatter plot with the same kind of code. Can you see? Just by changing kind equal to line, I'm changing the kind of plot which is available over here. Are you able to see this one? Yeah, guys? Yeah. So kind equal to line and kind equal to scatter changes the complete look and feel. So now I'm changing it to scatter and just see the output again. I think you can simultaneously do this in your Google Colab. You can copy my Google Colab in your own repository and try it. That's another plus point. Okay, clear all of you? Yeah. Now I'm taking the same plot now, adding up one parameter which is hue. Hue semantic is nothing but adding a legend. We saw the legends just few minutes before, right? With a different color showing what is the different type of textures being used. So suppose I'm taking the same thing, item MRP and item outlet sales, and I want to classify them based on item type. So can you see the same scatter plot is having different colors saying that pink refers to dairy, this refers to soft drinks and so on. So am I getting a better classification? Remember yesterday someone asked me this plot refers to which one? Scatter plot. Do you remember? Can we get the dotted points? Like what is the value of each and every dotted point? Yeah. Yesterday only we had a discussion and I mentioned that this is not doable in Matplotlib, but we will have a look later. So this is an example of a hue semantic which helps us to classify. If you see, it helps us to classify based on another one variable, third variable, which was not doable in Matplotlib. Matplotlib was somewhere restricting yourself to show only 2D kind of a graph. But here in Seaborn, we can create a classification with the help of third variable. Is that clear? This colors is not doable in Matplotlib. That comes up with another extra add-on feature, not the basic Matplotlib. This hue feature is purely of Seaborn. That's why we are using Seaborn here. Can you see that I'm calling for sns.rel plot? Yeah. So this is the official documentation. See this one. This is a figure level facet grid kind of a plot where you can create different type of plots just by specifying what kind of plot you want. Yeah. Is that clear, all of you? We have a session on Plotly tomorrow. We have a session on Plotly tomorrow, guys. Today we are converting on Seaborn and tomorrow we'll focus on Plotly. Matplotlib limits yourself to basic visualization. Seaborn takes you to the next level of visualization. Take it in that way. Okay? Is that clear? So see for the line plot. See line plot I'm creating and I'm adding hue semantic of the outlet size. Can you see? I'm categorizing them with the outlet size of medium, high and small. Are you able to see this? So this is the next example where I'm taking item weight and item MRP and I'm categorizing them. Are you able to see? It's more complicated because I'm taking complete data. If you want, I can limit here to first say 15 records and let's see what's the output. Can you see the output? Yeah, see the output now. Are you able to see the blue one refers medium, the orange one refers high and the green one refers small. So you can see the classification with the help of hue semantic, HUE, which helps us to add on a third variable in the bivariate analysis and helps us to classify it with the different colors. Can you see? Yes. So which one is more interesting? Again, a question for all of you. I hope now visualization is more interesting and you're enjoying it. Any questions till now? Because we are moving to the next few plots, which you can check it. So these are the different visualization which is doable in Seaborn. The next library which someone asked right now is even more fascinating, Plotly in Python. Yeah. Now here comes the next one, which is the bubble plot. Here we are putting a bubble plot with visibility scaled, and we are increasing the kind. Just let me tell you the size. Okay, I'm just running this output and see the size. Can you see the bubble plot, all of you? This is a bubble plot where I am focusing on the different sizes. Now this sizes of the scatter plot changes as per visibility scale. If you see the code, I'm giving a size parameter. The same code where I'm specifying kind equal to scatter, I'm adding up one more parameter which is saying size equal to visibility scale. Can you see this? So if you see, visibility scale for 0 is very less shaded. For 4, it is even more zoomed in. For 8, it is zoomed in. And same goes for 12, 16. Can you see that? Are you able to see? The 16 one is looking even more bigger as compared to the other dots. So you can create different type of dots here. That's what I want to show you. That's a bubble plot. Changing the dimension as per the value. If you want a plot which shows up that I want to see the scaled area more in my sales region, so I can easily see those data points from the plot which is visible over here. Yeah, it's there in my Google Colab. So those who have got my link of Google Colab can easily check in and can take a copy of my code and check it out. So is it clear till here, all of you? How are you liking it, the visualization part? On what basis the size is increasing? See, visibility scaled is one column in my data. Let me show you. Visibility scaled is that one particular part which is there in my data, and it has a range 0, 4, 8, 12. So it is taking those selected range, and based on that, it is creating a type. So inside relationship, so what is the first thing which we are doing? We are creating x-axis as an item MRP, y-axis is item outlet sales, and I'm creating a scatter plot out of that. And over there, I'm creating a divisions based on the visibility scale. So I'm giving the type. Can you see here? I'm giving the size which should be based on visibility scale. What is this visibility scale? Is nothing but the item visibility, the column item visibility which is already there. Is that clear, all of you? Sharing the Google Colab link right now. My name is there, Radhika. I will not do it again and again. Please check on this code. We can run. Anaconda is a base, guys. If you can run anything on Anaconda, it's obviously doable here in Google Colab. Anaconda is a base. Yeah? So can we go to the next one? Can we have a look on the next one? Okay, so just a question. What do you think this kind of plot it is? What kind of plot it is? Any guesses? Can anyone think about it? Here I am creating three different plots with outlet size medium, outlet size high, and outlet size small. I'm creating one bigger plot with three subplots. Can you see that? I'm putting it in the chat box. How many of you, okay, anyone, can you put the Google Colab link in the chat box, please, so that others can get it? Are you able to see that? No, it's not a pair plot. Pair plot is a different thing. Pair plot takes up two types of plots. One is a scatter plot and one is a histogram. Yes, it's a subplot where I'm dividing the data based on the item visibility and item weight. So I have item weight, item visibility here, and I'm dividing the category over here with the help of item size. What is my outlet size? So this is a plot for outlet size medium. This is a plot for outlet size high. This is a plot for outlet size small. So can you see that I have three different plots coming up over here? So isn't this a plus point that I'm able to get the classification of outlet size medium, high, small? Yeah? Ignore the background voice. That's my son. Yeah? It's not visibility scale, it is item scale. Item underscore visibility. Based on item underscore visibility, I'm putting a category like this is the visibility scale thing. Check on my code again. See the code. I'm creating a hue of visibility scale, and that is based on the item visibility. I'm based on that I'm creating this particular different shades. Can anyone please put a Google Colab link here because I have given 1,000 number of times. Are you able to see my link? I did it right now. With my name, can you see my name, Radhika? I did it right now. Okay. 1 second. One minute. Maybe my messages are not clearly visible over here. I'll have to put it on the community, and in the community forum you'll get it, guys. For now, I would request you, can you please go through what I'm teaching right now? Maybe you can check in later and check in the different structures. I'll be taking the last one for now because others is going to be an activity for you. The last one is nothing but a pair plot. Can you just see this one? Pair plot. Okay. Visible in app in a way like, okay, can anyone go to the YouTube app and check in? Yeah? 1 second, 1 second, guys. Okay, so yeah. Am I audible, all of you? Yeah. So this is a pair plot. Can you just check on this one? Okay. This is a pair plot. So this is one example, which is a species data. I'll tell you the species data has different type of categories. Okay. It has a it includes a categories like sepal length, sepal width, petal length, and petal width. And this is a pair plot which is showing up. Can anyone think about it? What is this pair plot all about? Any idea? Yeah? Can you guys think about it? What is this pair plot? This pair plot shows up two types of plots. If my x and y axes are different, then it will show up a scatter plot or a line plot or something. On the other hand, if my x and y axes are same, it will show up a histogram. So can you see the x and y axis? This is the x axis, which is sepal length, sepal width, petal length, and petal width. And the next one is given over here. Sepal length, sepal width, petal length, and petal width. Suppose this is an example I just want to say. Just focus on the example and you can see that sepal length, sepal width, petal length, and petal width, all the four values are placed on the x-axis and y-axis. Are you able to see this part? All of you? It doesn't show the correlation, guys. Correlation is a different perspective altogether. I'll show you the code for correlation with the same example, but for now, just focus on this example. This shows up an example, this pair plot. This shows up an example of a different perspective. If you have the x and y axis as same, then it will show an output as a histogram. On the other hand, if you have the x and y axis different, then it will show up a scatter plot. Can you see that? All of you? See, if I have sepal length and sepal width, petal length and petal width, then I am getting a scatter plot. On the other hand, if my x and y axis are same, then it is showing like a histogram. This histogram is like an area plot. Different type of histograms are there. Distribution plots are there in Seaborn. And one among them is area plot. Can you see this part? Yeah? Are you able to see? Yeah. So this is a pair plot, guys. The pair plot shows up the relationship between the x and y axis, and accordingly it shows up the output. Okay. Yeah. Now I'll show you one example for a heat map. You wanted to see the correlation thing, right? So there is one thing called as heat map. Heat map shows up something which is nothing but the correlation of different variables together. So if you know what is correlation, correlation is something which focuses on, yeah, yeah. Can you just see the heat map now? Heat map shows up the correlation of the number scale. First of all, I'll show you this correlation separately, iris.core. It shows up a tabular structure with the values from -1 to +1. So these are the values which is coming up, iris.core, which is coming up over here, which shows up a tabular structure. Can you see? Sepal length, sepal width, petal length, and petal width having a value from 1 to -1. Yeah. So heat map shows up the same kind of a correlation in a tabular format in a shaded region. Can you see this? Are you able to see this, guys? This is a correlation plot which is only possible with the, yeah, if we do n naught equal to true, we'll get the values here in the heat map. Okay, so if you do n naught equal to true, just see the difference which is coming up. We'll get the values of those correlation in those grid-like structure. Are you able to see? All of you? Iris is a data set. If you go to the Google Collab link, I'll post it again on the community post my session. Don't worry about it. Towards the end, I have taken an Iris data set where you will see that this is a small data set. It's like a dummy data set which is highly used in data science analysis. Okay? Clear, all of you? Yes, that's great. So these were the different plots. The activity for you guys will be posted immediately. It's nothing but you'll have to try the different ones which I have left. The different type of histograms and the area plots, the density plots. We had a look on the different plots like violin plots, box plots and everything, but there are different plots like swarm plots, strip plots, which you can check from Seaborn. Try this at your end. This is going to be our activity. Okay, so just give me a while. I'll post it in the community. The link of the community is given by Paridhi on the YouTube channel. So once it's available, you can just check in and you can have a look on the same. If you have any questions, you can shoot it right now. Yes, questions. How did you like it? Now, one question from mine. Which one is more feasible? Is it Matplotlib or is it the Seaborn, which is more doable? I have mentioned today's assignment. I am going to put this notebook on the forum right now. I'm going to do that right now. And once this has been done, Okay. Yeah, so data visualization using Python. In this forum, I'm going to put the link. And you'll have to actually have a look on this particular example, which I did right now. I'm going to give for Matplotlib as well as Seaborn. Try out the different examples which I have done in the for this Google Colab link. Okay, all of you. This is for Seaborn and this is for Matplotlib. You will see a name getting populated with me, that is Radhika Omkar Datar, and over there you will see the complete example of visualization. Using Matplotlib also, I'll put it right now. I'll post it right now. So both the things are here. One is for Seaborn, one is for Matplotlib. You will put a hands-on of this Google Colab. You can create a copy of that. Okay. We don't have any practice assignment. It is all about doing the practice of what I did. See, it's too early to come to a conclusion that you will have all the type of practice exercises just by 1.5 hours of session. These are very huge libraries. So first you'll have to understand the concepts thoroughly. Then only you can jump in to have a look on different kinds of, or I can say the different examples which is visible. Okay, clear all of you? Any questions? Any queries? The today's, I think the deadline for all the assignments is on Tuesday. It's on Tuesday. You'll have to complete it and send it across. I don't know where you have to send it, but yes, Let's Upgrade team can update here. All they have to do is do a research on the links which I have given right now. Assignment, again, I'm repeating, go to the community forum. Over there, I've posted the link of Google Colab for Matplotlib as well as for this particular Seaborn. Okay, so please go it over there. And over there, first let's try out to do it because we have a deadline till Tuesday. Please practice the exercises. Okay. It's not necessary to upload in Google Colab. Yes, you can do it because it's going to be an online repository. Yeah, that's all from my end. And yeah, any other questions? So tomorrow we'll have it for Plotly, all of you. I hope you understood the session for Seaborn because Seaborn is very big library and it is very we have a time constraint to actually limit ourselves to understand about Seaborn. But yes, I hope you had a wonderful session and you understood the concepts thoroughly, all of you. Okay, that was great. See you all in the next session, and yeah, that's going to be the final session for Plotly. Okay, cool. Thank you, all of you. And yeah, keep practicing more research, and that's how you'll it will be beneficial for you. Thank you, all of you. See you all tomorrow. Okay, then tomorrow one more session for Plotly. Plotly is the last data visualization library for Python. Any more sessions for data science? I get you have to stay tuned with Let's Upgrade. I'm not a person that do a reply on this, but yeah, please keep on practicing for Matplotlib as well as the Seaborn library which I have given over there, the Google Colab repository. Okay. Yeah. Thank you, guys. I'm going offline. See you in the next session. Thank you. Bye. Assignment